Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to lecture 15, Organic Chemistry 1. Today we will cover the rest of chapter 4, Structure and Stereochemistry of Alkanes and Cycloalkanes. Cis-Trans isomerism. If we have cycloalkane ring, the term cis is used to signify that the two groups are on the same side of the ring, while the term trans signifies that the two groups are opposite sides of the ring. Here, cycloalkane ring, for example, if they are on the same side, they are cis. If they are on opposite side, we say they are trans. Consider the structures of cis 1,2-dimethylpropane and trans 1,2-dimethylpropane. Which compound would you expect to be more stable? Explain your choice. Predict the difference in energy between these two compounds. Cis means that the methyl group are on the same side, and they are here on the same side, up. What I do, I really take the structure from 2D to 3D. It's very easy, using several programs are available to do that. Now, if I look for this will be in the back. I can see that the CH3 are eclipsed and two hydrogen are eclipsed. If I draw it for Newman projection, that's what I see for this one. And in the back, CH3 and hydrogen. So it's very clear that you have here CH3 eclipsed, torsional strain of about 11, as we covered in the previous lectures. Here HH eclipsed 4 kilojoule per mole. For the trans, when one is up and one down, we can say one in front and one in the back. Again, 3D, from 3D I draw Newman projection. Here you have two CH3H eclipsed, 6 kilojoule per mole each. So because of the high torsional strain in the cis, it is less stable, and the trans is more stable. So van der Waals force strain makes cis isomer less stable than trans. Predict the difference in energy. Okay, we have in this one 11, in the cis 11 plus 4 torsional strain. Here we have 6 twice, so minus 12, 3 kilojoule per mole. Experimentally, the cis upon combustion release 3,371, while the trans 3,366. So the trans is more stable by about 5 kilojoule per mole. In the two conformations of trans 1,2-dimethyl cyclopentane, one is more stable than the other. Explain why it is. If you look for this structure, CH3 is up, CH3 is down, right? So if this is up and this is down, this is trans. But we can hook CH3 on that direction and CH3 in that direction. They are trans again, up and down. Which conformer will be the more stable? What I do, as I said before in the previous slide, I take this one, put it in 3-dimension program, 3D program for this one too. Okay, now I look for the molecule from this carbon in front, okay, and this will be in the back. I can see CH3H, okay, eclipse to one another, and here CH3H, and again CH3 is close to CH3. I put it in here. This is in front and this is the back, is not clear. Okay, in this one again you can see that CH3, okay, in that gauche type of structure around 60 degrees, while when we have it in this CH3, you can see that the CH3 are far away. It's almost anti-conformation and will be less torsional strain and will be more stable. So this structure is a more stable. Cis-1,2 dimethyl cyclohexane. Cis means that two CH3 are on the same direction. Look at the model. CH3 and CH3 are on the same direction, up, and CH3 up. Axial, equatorial. Flip to the other chair form. The axial became equatorial and equatorial became axial. So we have here axial, equatorial, axial, equatorial. These two conformers are of the same energy, so they are at equilibrium 50-50. For the trans, we have CH3 down, CH3 up. If that's the case, we have here CH3 up, CH3 down, equatorial, 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 flip, became axial, axial, equatorial, equatorial, less torsional strain, and that will be more stable, and the equilibrium will be shifted toward equatorial, equatorial. Axial, axial will be less stable. Polycyclic system like Cis-Decalin and Trans-Decalin, two 6-member ring linked together or fused together. The relation between these compounds is stereoisomeric. They are stereoisomers. These two compounds are not interconvertible by ring flipping. They are two different compounds with different physical properties. Which isomer is more stable, and explain? This is the Cis-Decalin, and Cis-Decalin, the two hydrogen are on the same direction, and you can see from the model that the molecule is mobile, okay? You can flip it, okay? The best way to analyze this molecule, to draw it in 3-dimension and put the molecule in a way that you can easily draw the Newman projection from carbon 8, carbon 10, 6, and carbon 4. Number system 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how we number the carbon. Okay? Now, if you look at carbon 8, this one, you will find CH2, H, H. The one in the back will be 9. Carbon 9 has 2 hydrogens, 1, 2, and has CH2. So H, H, and CH2. The CH2 here is going to carbon in the back will be carbon number 1, hydrogen up, and CH2. So this one has hydrogen, CH2, and CH2. This is carbon number 6. Carbon number 6 has CH2 going to carbon number 4. Here is CH2 to carbon number 4. The carbon in the back carrying CH2. Then 2 hydrogens. This carbon carrying H and H, H and H. And we have here Newman projection. Concentrate now with me on that. We have CH2 carbon number 7 and CH2 carbon number 10. They are in gauche, angle 60 degree, right? And we have 10 and 5. 10 and 5. And we have 5 and 2. These are torsional strain for 3 gauche. 7 and 10, 10 and 5, 5 and 2. Okay? Going to trans. The trans is rigid. You can't move it. It's rigid. Okay? So, once again, transfer this to the 3-dimension. Put this 3D in a way that you can draw easily Newman projection. Again, this is carbon 8, 6, and 4. And see now you have 7 and 10 are gauche, and 5 and 2 are gauche, only 2. Okay, torsional strain. While the cis has 3 torsional strain of 3.8 kilojoule per mole. So accordingly, trans, of course, will be more stable than the cis. Here are some examples of cycloalkanes in nature. From terpenoid class, we have here menthol structure. Here we have camphor structure, bicyclic. From steroid, we have folic acid here, and also from steroid, testosterone hormone. I hope that we have now covered all about stereochemistry of cycloalkane. See you in the coming lecture. Bye bye.